Mr. Chairman, ladies and gentlemen. So my talk is about, when it comes on the screen, carcass video image and the use the potential use we can make of them in the genetic evaluation on the breeding program. Just a very quick background, because you've probably seen that now. Ireland is a very agricultural country, roughly 2 million cattle, a bit less than 1 million beef cattle in Ireland. No small size herd, 14 cows on average, 6 major beef breed, continental, so Charolais Limousin, then traditional Angus, Simmental, Hereford, and Belgian Blue. Large use of crossbreeding. On the destination of these calves born every year, well, 15% roughly go to replacement, get the next generation. 16% are exported live, and 69% are sorted in Ireland. Beef breeding objective, well, it's probably very common to every country, that one. But I mean, there's 4 big blocks in the big beef breeding objective in Ireland. Blocks where a farmer can act on profit. So one block is calving, no calves, no money. The other block is winning export. Part of our market is toward export. Another block is beef carcass, for all these cattle slaughtered in Ireland, finished in Ireland. And the last block is replacement. So we're going to concentrate, as you might think of it, is on the beef carcass block, because on that one we'll find traits like weight, carcass weight. We're going to talk quality, carcass quality, and feed intake as well. All these 4 blocks are concatenated into one suckler beef value and given back to the farmers. Currently, if you want to act on this beef carcass block of our beef breeding program, the tool farmers got coming from factory. And in that respect, we are quite fortunate in Ireland to get all factory data. But what we get is rather common across Europe, as in we get the carcass weight. And carcass quality is assessed via the Europe conformation. The Europe grading for conformation and fat. So on your far left, you got the conformation, so the big guy and the skinny guy. And then in the middle, you got the fat grading, where you got the lean guy and the very fat guy. And these are the tools we can use to build a selection index currently for carcass quality. We're going to use that because that's what we get, that's the phenotype we have. So the question, the motivation we had in Ireland is, can we do better? Can we go further? Or actually, can we go deeper? Can you see what's inside the carcass and try to play with what's inside instead of staying outside the carcass? So can we get new selection tool for carcass quality? That's the question we have to answer. An objective in two sentences would be, can we get new traits, new phenotypes, and we'll see about digital images, and mostly, is that interesting for farmers, for the industry? That's the 2 questions we put in to answer. So as a trait, we're going to use the data. We're going to use the first set of data, and we are very fortunate in that respect in Ireland, is what I've called the primal cuts. In Ireland, we had access to quite a few carcass dissections already made for me. So one part came from a research center in Grange, for around 400 steers mostly. And the other set of data came from a commercial partner, which gave us around 600, mostly heifers. And all this, so in this data set, 2 data sets, one carcass was cut up into 14 primals. Probably know the names of these primals. They can be spelled differently according to the region, but you can see on the carcass where they are. And mainly you got what we call where the value of a carcass is, mainly is on the back of the animal, on the back leg. Okay, all this chunk of meat that can cook very quickly. On the front part of the animal, the forequarter in white on the picture, there you got the shoulder, we got some slow roasting meat, and on the rest of the carcass, where it goes into mince meat, dice, and stir fry meat. So we had access to all that, and that was great because that's expensive to get. First study we did was a genetic study. On that slide, just summarize heritability find. Heritability is sort of a part of this phenotype you see, this carcass weight or this cut weight that can be transmitted to a progeny. That's the interesting part for a breeder. What if I buy this bull? Is he going to transmit most of his cut weight to his progeny or not? So we got different sort of heritability in there because our data set was rather small, okay? And they go from very low heritability, 0.03 or 3%, to very high, okay? The round, what I call the round, which is the back leg, was at 86. The standard error were very high in there, okay? But is that useful in animal breeding? Okay, so do we need to create new traits? We got that, actually. That could be quite interesting. So that's interesting for farmers and the industry, it is. As soon as you talk cuts, go deeper into a carcass, you get attention of farmers in the industry. Is there variability? I can't say that word. Yes, there is selection potential there. There's heritability where we can play with. So yes, there is. Are they available? That's the tool you need. And that's not possible. You can't imagine dissecting all carcasses going through factories to get these phenotypes. So that's a big no. So we have to find a new way of getting this as cheap as possible. Okay, the other thing we are also, which is well installed in Ireland, is mechanical grading. It's spread across, I think it's 24 factories in Ireland, and that covers more than 80% of the production slaughtered, okay? And mechanical grading is doing what the human does when giving the Europe and fat grading, okay? Prior to that, an official person from the Department of Agriculture, his job was to grade carcasses. And that can be done by a machine. It's done across the world, Australia, doing it, in the US as well. A carcass, you take a picture of a carcass, actually 2 pictures of a carcass, process the images in a computer, and get some Europe and fat grading. So that is done since 2003 in Ireland. The thing we have is all these images have been stored in the database since mid-2005, roughly July 2005. These images have been stored. Okay, so it's quite a bit of images now, 15 million images. That was probably up to last year. And the trick is, can we use these images to get the cuts instead of dissecting? So we thought, right, okay, we're probably not going to predict all 14 traits. What we've done is we've asked a panel of experts from the research center, from the industry, from factories, given these 14 primal cuts, and say, right, group them by retail value. And the grouping is logical. That's what one would expect, okay? Because that's what you get on the shelf when you go and buy your meat on the supermarket. The high prices is in your entrecote, your dorsal muscle in black. Then a bit cheaper, you got your back leg, you got your steaks, and then you got your roast, shoulder, and the chuck, and then the rest, mince meat, diced meat. That's the sort of low price meat. So we're going to work on 4 wholesale cuts. And what we're going to do regression. We're going to do prediction equation from images to wholesale cuts. The images, we're not going to work physically with images. We're working with a variable behind the images. Okay, there's 400 and so variables. Could be length, could be surface, volume, contours, color, to predict 4 wholesale cuts. We're going to use a calibration validation procedure. So build the equation on one set of the data, validate on the other set. And we're going to do that for steers and heifers. So we're going to have 2 different equations for them. The accuracy of this prediction are very good. And these are the accuracy in the validation data set, all right? So for steers, if we look at the cuts, I didn't mention the name of the cuts. So we got the lower value cuts, medium value cuts, high value cuts, very high value cuts. I stayed very logical in there. Okay, so for steers, accuracy ranked from 0.84 to 0.93. Okay, so the best bit of a carcass predicted was a back leg, which is on the picture. If you see a picture, it's quite, it's the most obvious part. And the very high value cut, which is the dorsal muscle, that's a bit harder to pick on the picture, hence the low accuracy for very high value cuts. The accuracy was a bit lower for heifers, mainly because my data set was much smaller. We got prediction equation. We're happy with the accuracy of prediction equation. We've stored images in our database. We can generate new phenotypes now. We just apply the equation to the image we got installed in the database. So that's what we've done. And so far, I've done it across 14 over 24 slaughterhouses across Ireland. I can't tell you exactly where they are, but they're spread across the country. And bang on, you got an access to a large supply of data suddenly. We did a genetic study on these predicted weights. So this table where there's too many numbers, just the diagonal is your heritability, so a part which is expected to be transmitted. So heritability, if we just look at the last four columns, they rank from 0.2 to 0.4. And then genetic correlation. In blue, you got the boys, the steers, and in pink, you got the girls, the heifers. Okay, that's my color code. Genetic correlation, they're very strong, which one would expect between this mid-cut, because they've been grouped by retail value, but some of them, and probably most of them, share the same muscle. So they are expected to be strong. We studied as well the relationship between these cuts, these predicted cuts, and the rest of the traits in the evaluation in Ireland. So this sort of picture gives you a snapshot of sort of correlation I got with the other traits. So high correlation with carcass value, okay, carcass cuts and carcass value, correlation between 3.5 and 6.9. With auction prices, that's a trait we use in the evaluation. I think Ross after is going to come on some of these traits. Sort of moderate correlation with farmer score for calf quality, which is a score that the farmer gives at winning when the calf is around 10, 12 months of age. The farmer is asked to score the calf. Is it a good calf or bad calf? 1 to 5. So that's the score. Ross is going to talk about them straight after. And, with linear scoring and with live weights. Okay. You might see the low correlation with live weights. That's because all these cuts are adjusted for carcass weight. So the link between weight and weight is broken there. Okay, we don't know that. That's useful, is that, is the industry would be interested in that? Well, that's it. Are we there yet? Nearly. Is that interesting for farmers still? Yes, it is. It is. And they are very interested with that. Is it available this time? Yes, we have a supply of predicted cuts, nearly routinely. Okay, we have to streamline the process, but the basic is there. Is there variability? Yes, we've got heritability, we've got correlation there, and there's a way of selecting in there. Correlation with other trait is done. Now the other question is benefit. Can we quantify benefit for the Irish industry? So that's a cost-benefit analysis. And just briefly, our breeding goal, you got these 4 blocks we've seen at the beginning. If we concentrate on the third block, the carcass block, built with predicted cuts, that's our objective, that's our quality aim. We can forecast for scenario. A scenario where our selection index, so the tool the farmer is going to use to act on his cattle, an index 1 which is built on live weight only, an index 2 where we had carcass weight, an index 3 where we had Europe grading, an index 4 where we had the predicted cuts, and then even did an index 5 where if we had more accurate prediction. So that's the scenario I've tested, 1 to 5. And to summarize it in probably one line on this table, so that's the benefit, the potential benefit, added benefit over 10 years of this scheme. So if you have a scenario using an index with only live weight, and an index with carcass weight only compared to an index with no carcass weight, well, there's a huge benefit there, plus 7.3 million added. Okay, so added slaughter rate is hugely important. Using Europe grading, you increase your benefit by 0.6 million euros over 10 years. But then using predicted cuts, you get another big jump there. Okay, price 2.4 million euros. And if you make more accurate prediction, you can even add a bit more there. So there's definitely a benefit for industry to move towards these new traits. Conclusion, using phenotypes from images is feasible. Okay, we can have access to a supply now of it. It's beneficial for the industry. There's variation to play with. There's association with early predicted trait, like calf price, for instance. And we can build a new selection index for farmers. So to answer the two questions at the beginning, is it possible to create new traits? Yes. And is that interesting for the industry? It is. So future research now, still got work to do. We can always strengthen prediction equation, notably on the heifer side, and get some young bulls in the category that we don't have at the moment. Investigate meat quality, okay, and maybe other technology. Beef genomic is knocking at the door, so in time that will include the carcass cut trait. We could expand this knowledge to sheep. I mean, in the UK, a huge research has been done via using the same technology and the same prediction, system prediction equation on sheep. We could build on that in Ireland and explore other way of collecting this phenotype. We will need to upgrade this equation, see we're still in line. So we need to find a way of collecting carcass dissection on a more routine basis. Okay. So, certainly the beginning. Thank you very much.
Hey, thanks, Thieery. So, any questions?
Yeah, Alison, I guess I have a question about how producers get paid for their cattle, and how do you see the value transfer if this works that way?
True, yeah. So at present, producers are paid on carcass weight plus Europe grading. Okay, the carcass weight on every factory has its own grid to include Europe gradings. Okay. The strategy there, because there's a trick now to try to shift this payment. That would be the ideal goal. Get the factory to use these predicted cuts instead, or I don't know, as a plus with Europe. I don't know what the way to. So try to interest them. And so far we have started to engage with factory, and they're quite receptive to the technology because they're using VI anyway. So they got sort of trust in there already. What they need to see is if they can gain something from it for themselves. If this technology can help them sort their carcasses a bit better, prepare their fridge or something, they will buy into it. So I guess on our side of a river is we're gonna probably see it like it happening in dairy when the protein indexes were introduced, nobody was paid on it, and suddenly the industry started to see a benefit for all this the processing chain, and shift the payment to that. And in my head, it's a bit. I hope it's how it's going to happen for beef. Okay, they're interested at the moment, so that's a plus. We're going to work with that, and hopefully the benefit will just make them turn their payment.
One more. We have time for one more question there.
Laurent Journeau from France.
Yes,
okay. Okay. My question is: the next step is a link with the meat quality or meat consumption. So there is some study in Europe with the use or the transfer of the system used in Australia, Meat Standard Australia. Do you have plan or project to link your studies on cuts with this approach more based on consumer needs or demand?
Yeah, thanks, Laurent. Yes, it's very important question because so far, I must admit, in Ireland, on meat quality, nothing that I know has been done, okay? But fortunately, we're acting on it. And there's a project at the moment between Chagas, ICBF, and I think UCD as well, to try to act on that. And it will involve more dissection, okay? So I might be able to strengthen my prediction at the same time. But the aim of the project is exactly meat quality. And collect for meat quality. What trait are we going to aim for? Is that only tenderness? Are we going to? Yeah, there's definitely a project kicking in at the moment, yes, in Ireland.
Okay, thanks, Thieery.
Thank you.